Good evening, class. We are looking at college algebra foundation or prerequisite. Number sets, natural numbers or counting numbers or positive integers. Contain the counting numbers 1, 2, 3, 4, or we represent it with n from 1 to infinity. Of course, the three dots are called ellipses and indicate the number. The numbers continue forever indefinitely. Whole numbers. If we add a zero to that, it becomes a set of number known as whole numbers. We represent it with W. If you go on the left side and add negative numbers as well, so becomes integers, whole numbers, and the opposites or negative of every natural number. Rational number. Any real number that can be expressed in the form of a over b, where a and b are integers and b is not zero. In other words, if we have a fraction where the top and the bottom are both integers. Irrational numbers, any real number that is not rational. Examples are square root of 2, cube root of 4, pi. Remember, pi is 3.14159, and it continues indefinitely. So if a decimal is repeating, is a rational number. If a decimal ends, it's terminating, it's a rational number. But if it's non-terminating, it's an irrational number. And a real number contains all of those, the union of the rational and irrational numbers. So everything combined, we call them real numbers. Absolute value. A given number's distance from zero on a number line. That's the definition of an absolute value. Therefore, the absolute value of every real number is either positive or zero. So look at this distance. 5 units from zero. Look at this distance, 5 units from zero. So both of them have the same absolute value, namely 5. So the absolute value of a number n is written as absolute value of n, and its absolute value of 5 is 5. Absolute value of negative 5 is also 5. So opposite numbers have the same absolute value. Zero exponent. For any non-zero real number a to the power of 0 is 1. So this is the one we are referring to, everybody. Now, I am reminding you of all exponential rules. A to the power of 0 is 1. A to the power of m times a to the power of n is a to the power of m plus n. This is the product rule. This is the power rule. A to the power of m to the power of m, you multiply these two. AB to the power of m, you raise each one to the power of m. A to the power of m, a to the power of n, and then it's a to the power of m minus n, called the quotient rule. This ratio to the power of n works like this one. Both of them are to the power of n. And any number to the power of negative, it's 1 over the same number to the power of positive. So, and 1 over a to the power of minus n is a to the power of n. Meaning, if you put these two together, basically they say, if you have a negative exponent, just move it up or down, make it positive. And if it's a over b to the power of negative, you write its reciprocal to the power of positive. For example, 3 to the power of 0 obviously is 1. Negative 4 to the power of 0 is obviously 1. And negative 4 to the power of 0 is negative 1. I want to make sure you understand the order of operations, because in this case, first you do this one and you get 1, then you multiply. So first you raise it to the power of 0, you get positive 1, and the negative gets multiplied by it, gives you negative 1. So that's dealing with zero exponent. Zero exponent. We want to find each product. If we look at this one, we are going to go with this theorem, and we're going to add 4 and 7. We get y to the power of 11. If we have this one, we can do it in one shot, but let's do it in two shots so it becomes clear as to what we have. So we put the numbers next to each other and the z's next to each other. So now we realize this is 6 times 9 times 2. 56 times 2, 108. And z to the power of, add them up, 5 plus 3 plus 2, which makes it power of 10. Again, just reminding you about the rules. We want to simplify this. So simply 5 to the power of 3 times 2, or 5 to the power of 6. For a question like that, they don't expect you to actually write out the answer, but rather it's about the exponential rules. In this case, we are going to use the power rule in essence. So this gets raised to the power of 3, and this gets raised to the power of 3. And so this is 3 to the power of 12, and x to the power of 2 times 3, 6. All right. Before we move on, notice the denominator is not supposed to be 0 anyways, and now we use the power. So this one, 2 to the power of 5 gets raised to the power of 3. B to the power of 4 gets raised to the power of 3. So 2 to the power of 5 times 3, which is 15. B to the power of 4 times 3, which is 12. And again, the same thing. B can't be 0. We are looking at the exponential rules. Like terms are terms with the same variables raised to the same powers, such as negative 13x cubed, 4x cubed, and negative x cubed. We can combine like terms. A polynomial is a term of a finite sum of a term, is a term or a finite sum of terms with only non-negative integers, integer exponents, permitted on the variables. So the idea is that you have one or more than one term, but the exponents must be non-negative, must be whole numbers. Can be 0, yes, that means a constant, can be any positive value. So now we are going to stick with this combining like terms. We can combine this as follows. Because it's a plus sign, all of them remain the same. Otherwise, if it's negative, first apply the negative sign, then you combine them. Notice I can add these two, and I get 2 plus 4, 6y to the power of 4. I can add these two and I get negative 3y squared and 7y squared. Negative 3 plus 7 is positive 4y squared. And then finally, these two 7y. So 2 plus 4 here, minus 3 plus 7 for this one, and 1 and 6. Remember, when we have just a variable, the coefficient, the multiplier, the number sitting in front of it called the coefficient. When it's missing, it's 1. Everybody remembers foiling first, outer, inner, last. You don't have to use the foiling. By now. You should be able to combine them in no time. But just for the sake of argument, if I want to foil, the first ones would be these two. So this would be the first ones. These two would be the outers. These two would be the inners. And this would be the lasts. So you should be able to do this in your head. The reason why is for the reverse process, which is known as factoring, okay? So obviously 6m times 4m is 24m squared. 1 times negative 3 is negative 3. This part is minus 18 plus 4, making it into negative 14m. Now, as far as the product is concerned, I hope you remember special products. If you do the foiling, x plus y squared is x squared plus 2xy plus y squared. X minus y squared is x squared minus 2xy plus y squared, and x plus y times x minus y is x squared minus y squared. Again, the reason we should know them is for the reverse process. When I want to go back, known as factoring. So I'm going to remind you of the synopsis of the factoring. Number one, we have a GCF, the greatest common factor. So first factor out any monomials. Then consider the number of terms. If we have 4 terms, we do it by grouping. If we have 3 terms, we may have a perfect square trinomial, such as a squared plus 2ab plus b squared is a plus b squared. You remember it from the previous page. Or a squared minus 2ab plus b squared is a minus b quantity squared. I used x and y in the previous page. It may not be a perfect square, but the second degree term has a coefficient of 1. In that case, you want 2 numbers, okay, 2 factors of c, such that their sum is b, and you write it x plus the first one, x plus the second one. And if the coefficient happen to be a, then we can use the trial and error or find 2 factors of AC whose sum is b, and write these factors as coefficients of 2 like terms, terms that when combined equal bx. So it's a little bit more complicated, but it's really not too bad. Reminding you of the difference of squares. If we happen to have only 2 terms, remember we had this in the previous page. A squared minus b squared, known as the difference of squared, is a plus b, a minus b. If it's the sum of cubes, a plus b cubed is a plus b times a squared minus ab plus b squared. What I want you to pay attention to this, okay, is not the same as this one. This has negative 2, this has negative 1. So this is a prime polynomial. A cubed minus B cubed is A minus B times A squared plus AB plus B squared. And again, take a look at this one and compare it to this one. This is not a perfect square trinomial. It's a prime polynomial. Also, both of them have one negative sign. This has a one negative sign in the first parenthesis. This has it in the second parenthesis. Again, reminding you of what you are supposed to do. So, and as always, you can check how by multiplication. So simple case, you just take out the y squared. So this is the product of y squared and 9y cubed. This is y squared and 1. So it becomes y squared times 9y cubed plus 1. I hope everybody's comfortable. You want to do this, you have to 1, 2, 3, 4 terms, you have to do by some sort of a grouping. And the grouping, you do the first two and the last two. If it works, fine. If not, the first and the third, second and fourth. If not, first and last and the middle one. So let's do the first two and the last two. So when we do that, the first one, remember how you know whether you have it right or not. You're looking for a common factor. So if we put these two together, we can take out the m, gives us p squared plus 7. And this one, we can take out the 3, and it gives us the same p squared plus 7. Because they are the same, then we are in good shape. So what do? You write p squared plus 7, and whatever is left. From here, m is left, from here plus 3, and you're done. So this was factored by grouping. Special products, resulting in special factoring. You recall this, as I mentioned. Sometimes we use a and b, sometimes we use x and y. So if you have a perfect square trinomial, how do you know you have it? So for example, this one, you see this one, the first one is 4p quantity squared. This one is 5q quantity squared. Is this the product of these two that we just came up with? Let me just write them here so you can see what I'm talking about. So this one is 4p quantity squared. This is 5p quantity squared. Now, if you multiply these two without the square, and then times 2, 4p times 5q, you get 20pq times 2, you get 40pq. So negative or positive makes no difference. If it's negative, we have this one. If it's positive, we have this one. So take a look. We do have that. So you want to check the middle term works, and this 2 is the key. It works. So we have this format, 4p minus 5q quantity squared. We do the same thing here. This is 13x squared. This is 4y squared squared. If you multiply these two, 13 times 4 is 52xy squared. Times 2 makes it 104. So that's fine. It's a plus sign, so we go with the plus sign. So plus 2. This is the key. The 2 must be there. Let me use a different color on this number. So this is important to know. We need this 2 or it does not work, everybody. You need this 2 or it does not work. So we're practically done. Difference of squares, x plus y times x minus y. And so this one is 2m quantity squared minus this is 3 squared, and it's this format. So 2m plus 3, 2m minus 3 in any order is your final answer. As always, you can check them out by multiplication. Difference of cubes, we went over that. I'm reminding you of those. X cubed minus y cubed is x minus y times x squared plus xy plus y squared. X cubed plus y cubed is x plus y times x squared minus xy plus y squared. And remember, we use a and b or x and y. The concept is important. So x cubed plus 27. So x to the third power, and this is 3 to the power of third power. So we are going to go with this format. X is x, y is 3. So replace it here. X plus 3. So literally you can replace it with y. So x squared, that means just x squared minus x times y minus x times 3. And then plus y squared, that means 3 squared. Now x times 3 or 3x, and this is the only thing you have to change is 9. 3 squared, change it to 9. Now, of course, you can go directly to the answer, but I just wanted to make sure we understand how that works. Fundamental principle of a fraction or lowest term of a rational function. AC over BC is A over B. In other words, if you have a common factor between the numerator and denominator, you can drop it. So anytime we have expressions such as those, we look for a common factor. Now, first, I'm going to give you a hint, and that is, if you look at the denominator, which is easier to factor, we have a common factor of 5p, so the answer is p plus 4. So this cannot be simplified unless the numerator either has a factor of 5 or p plus 4. So that really should help you find the answer, and doesn't have a factor of 5, doesn't have the factor of p. It may have a factor of p plus 4 because this is negative 4. So there are two ways to do this, and I'm going to look at it both ways. First and foremost, 2 is an easy number, is a prime number. So I'm going to write this as p, and then this one as 2p. Then I play with this number by picking up its product. So negative 4 is the product of 1 and 4, 2 and 2, and one of them must be negative. Okay? One of them must be negative. So what happens is that because this is positive 7, perhaps it's easy to see where we would end up with the 4, because if I put the 4 here, positive, and minus here, it works. And remember, just try 2 and 2, one of them negative, see if it works. First of all, 2 and 2, it won't work, because then you can try that it's impossible. If you change the sign for this one and you make this negative and this one positive, it just doesn't work. So then what do I mean by it doesn't work? Look at the middle term. This is 8p minus p 7p. So that's how it works. And I'm going to show you a second method in a moment. We can drop the common factor of p plus 4. And here's the final answer. So the second method of factoring this, so we said 2p squared plus 7p minus 4. We want to factor this. So in this case, a is 2, b is 7, c is negative 4. A times c is 2 times negative 4 is minus 8. So we want two numbers. The product is AC and the sum is B. So we want the sum to be B. First, let's just write them. You can write 1 and 8, 2 and 4, and I'll put a negative sign. One of them must be negative, okay? Because their product must be negative. Now, How do we write those combinations such that the sum is positive 7? If you make this one negative 1, this one positive 8, then it works out. So what happens is this expression is written as, let me see if I have enough room here, 2p squared plus 7p minus 4 equals, let me just write the 2p squared and then minus 4 here. And now we pick those numbers minus a p plus 8p. So you cut them in a format such that you can factor them by grouping. So if I put these two together, I can take the p out and I get 2p minus 1. And if I put these two together, I can put take the 4 out, and again 2p minus 1. And I hope you see that's how you do the math. Again, I'm showing you this method, but I guess this is simple enough because 2 is a prime number. You can basically do it in your head. All right. Multiplying and dividing fractions in general. If you have fractions you want to multiply, you multiply the top, you multiply the bottom. If you want to divide them, the second piece gets you write the reciprocal and you multiply. Needless to say, you can simplify it before you do that. So for example, I want to do that. Of course, right away, I can do the simplification and move on. But just to see exactly what's going on, I'm going to cut this into pieces so it becomes clear. You don't have to do this. It takes too long, but just for the sake of argument. For example, this is 2, this is y squared, this is 3 times 9. The reason I put 3 times 9 because I see 9 here. And this one is 2 times 4 because I see the 2, and I put y to the power of 5, or I can write y squared times y cubed. Again, do you have to write it in this fashion? No, you can just start simplifying right here. Drop the 9 and 27 and 8 and 2 y squared and y to the power. So as you can see, these two cancel each other. These two cancel each other. These two cancel each other, and we are left with 3 over 4y cubed. Let's look at this one. To do so, we are going to change this to a multiplication. That means we need the reciprocal of this, and we need the factor of each term. So let's start with the very first one. Because this is number 3, you have a p and 3p. Again, I think it's pretty simple. You look at negative 4, it's the product of 1 and 4. 2 and 2, and one of them must be negative, not both. So just try different combinations. Try different combinations. So if I put, for example, minus 4 plus 1, just as an example. See, you have minus 12p plus p gives you minus 11p. That doesn't work. So right away, it tells you it should be the other way around. So this needs to be positive. This needs to be negative, just as an example. All right. This one, 8p squared comes out. This goes up. 12p cubed comes out as 12p cubed times 2p minus 3. This one 9 comes out. So take a look at each piece. So again, this one I had it up here. This one you take the 8p squared out. It leaves you with 3p minus 1. This is 12. This goes up. This goes to the numerator, everybody. This goes to the numerator, and I hope everybody's clear as to why it goes to the numerator, right? Because you're dividing, right? So this goes to the numerator. And so this goes to the numerator. You take the 12p cubed out. 12p cubed times 2p minus 3. This goes down. This goes down. Becomes 9 times p plus 1. And now you start simplifications. Now again, you can put them next to each other, start simplifying in a couple of shots or in 2 shots. For example, you can see these 2 right away go away. So you can write the rest of them. I would do it in 1 shot, but just for the sake of argument, if you write this, then you see, for example, p cubed and p squared cancel each other. We get p, 12 and 9 can cancel each other. We get 4, and this is 3. And then 8 and 4 can cancel each other. They give us 2, and we get this one as the answer. So again, just to make sure we understand what's going on here, you can do it in 1 or 2 shots, everybody. It's your choice. You can do as you wish. We are going to move on, everybody. All right, we want to perform the operation. In this case, we want to add or subtract. And whether you want to add or subtract fractions, you have to have the same denominator. So you come up with the LCD, the least common denominator. And to come up with that, you need to factor both denominators. So this one is y times y minus 1, and this one is, first let me take the common factor of 2 out, so it becomes clear that this one I can take out the 2, and I get y squared minus 2y plus 1, and I hope you recognize this one as a perfect square trinomial, y minus 1 quantity square. And therefore, now we can write the LCD as 2 times y minus 1 square, right? You have to write every factor. You have to write the 2, you have to write the y, you have to write y minus 1, but this one has exponent 1, this has exponent 2. You go with the larger of the 2. So what does it mean? So this one is this, right? So if you look at this one and compare this LCD, you see that 2 is missing down here and y minus 1. So you have to raise this by a factor of 2 times y minus 1. You have to raise this by a factor of 2 times y minus 1. What about this one? You have the 2, you have the y minus 1 squared. You have to raise it by a factor of y only. So take a look. So this one, we use y. This one, we use 2 times. And again, let me use a different color so it becomes clear. So we need also the 2. So now the 2 of them have the same denominator, namely LCD. And so this, if I multiply these 2, this is 2 times, and we're going to do the foiling fast. Y times y is y squared. Y times minus 1 negative y, and then 2 times y is positive 2y makes it positive y only, and then minus 2. I'm assuming everybody can do that. And we rewrite it in this fashion. So to put them together, simply this one is 3y squared. So 2 times y squared is 2y squared plus 2y minus 4, and we just write this with the negative in front of it. This negative gives this. So combine this 2 into negative y squared, and this can't be factored. Okay, this must be 4 or negative 4. Complex fractions. As you recall, when we want to simplify the complex fractions, there are different methods. The fast and easiest way is to find the LCD for all the fractions and multiply the top and the bottom by it. For example, in this case, you notice a plus 1 times a is the LCD for the top as well as the bottom. Bear in mind, this is the main fraction bar. So we multiply the top by a times a plus 1. Top as well as the bottom. Multiply the top as well as the bottom by LCD, namely a times a plus 1. Now, I'm going to show you these steps, but you really don't have to write these steps. It should be this one. You can, skip it. But here's what happens, class. In this case, a plus 1 and a plus 1 cancel each other. You end up with a squared. In this case, a and a cancel each other. They give us just 1 times a plus 1 or a plus 1. That's the numerator. This cancels out this one. This cancels out this one. And this is what we get. Again, just a quick recap. This one gives you a times a. This gives you 1 times a plus 1. This one gives you 1 times a plus 1. And this gives you a plus 1 times a. So all you have to do is simplify. This becomes a squared plus a plus 1. This becomes 2a plus 1. And it can't be simplified. Even if you could factor the numerator that you can't, won't have a factor of 2a plus 1 because this doesn't have it. Again, reminding you of the exponential rules. This is a negative exponential rule. A to the power of negative n equals 1 over a to the power of n. And I want to remind you also of this one. Just flip it over. 5 halves to the third becomes 5 to the third, which is 125. 2 to the third, which is 8. Very simple. Rational exponents for all integers m, all positive integers n, and all real numbers a, for which a to the power of 1 over n is a real number. The nth root of a is a to the power of 1 over n. So, we also have this because it's being raised to the power of it. So when we have this one, it's easier to rewrite it as 125 to the power of 1/3, then to the power of 2, because or the square root format, let me use a different color. So this one would be the cube root of 125, which you know it to be 5. Square it and you get 25. All of them have the same base, namely 27. So basically, for the numerator, add up these two. 27 to the power of 1/3 plus 5/3, which gives you 6/3 or 2, and then 2 minus 3 gives you -1, and therefore 1 over 27 to the power of -1, which is 1 over 27. The fourth root of 16, you already know it's 2, but in case you can write it as 16 to the power of 1/4. 16 is 2 to the power of 4. And this 4 times 1/4 gives you 1. Again, do you have to do that? Not for a case like this. But what about this one? Please understand that the answer is -2, but you can write this as -2 to the 5th power. And then 5 times 1/5 gives you 1. It's important to know a negative number to the power of odd is still negative, but the power of even is positive. Radical notation for a to the power of m over n. A to the power of m over n is the nth root of a to the power of m, nth root of a to the power of m. There are two ways to write them. And so if we want to write a radical form and simplify, a to the power of 2/3, if you recall, becomes the cube root of 8 to the second power. It's important to know the denominator is the index. This is called the index. And you all know cube root of 8 is 2. 2 squared makes it 4. -32 to the power of 4 over 5. So with this format or this format, it's easier to go with this one. 5, the denominator becomes the index and the numerator becomes the exponent. And of course, this, you know it to be -2. So -2 to the power of 4 is +60. When we want to evaluate this, it's not always a. We write it as an absolute value of a if you have any doubts. Generally speaking, if n is an even positive integer, then the nth root of a to the power of n is the absolute value of a. If it's odd, it's a itself. So the fourth root of square root of p to the power. If you don't know anything about p, you have to go with the absolute value of p. And here's the reason. You do the order of operation. First, when you raise the p to the power of 4 becomes something positive, and the fourth root of a positive number is positive. That's why you put it in an absolute value. If they said variables represent positive entities, then you don't have to write this. All right, this can be done in one shot, but I'm going to show you in a couple of steps. First of all, this is 4 to the power of 2. This is m to the power of 4 to the power of 2. This is r cubed to the power of 2. So we can write it in this fashion. And now these two cancels out the index. However, you put it in an absolute values. Now, can you take the 4 and m to the power of 4 out? Yes. Why is that? 4 is a number and it's positive. m to the power of 4, because this is an even exponent, is positive. You can take it out, but not r cubed. What about this one? 6 and 6, they cancel each other, but you have to put this in an absolute value. And again, the reason why, because first you raise this to the power of 6, becomes positive, and the 6th root of that is positive 2. Rules for radicals for all real numbers a and b and positive integers m and n, for which the indicated rules are real numbers. When you multiply them, when they have the same index, you can put them under the same radical. Square nth root of a times nth root of b is nth root of ab. If you're dividing the same thing, you can separate them or put them, you can go back and forth, okay? And if they have two indices, you have to multiply by each other, okay? Because this is a to the power of 1 over n, and just for the sake of argument, so this is a to the power of 1 over n, 1 over n, okay? And because of that, it's to the power of 1 over m, okay? And it makes it a to the power of 1 over m n, just this one. All right, so if we are looking at this, we can put them together. 6 times 54 results in 324 and gives us 18. By the way, if the number gets large, you have a difficult time seeing how you can simplify them. You can take this out as 2 times, you can put it in as 2 times 3, and then 54 is 6 times 9, actually. 9 gives you, comes out as 3, and this is 6, and this is 6. So 6 times 3 is 18. That's one way to do that. This one is the cube root of, remember, the exponent missing is 1, 1 and 2, they result in 3, and an odd just gives you the same m out. You don't need an absolute value because the index is odd. We separate them into 2, and then you know 64 comes out as 8. Square root of 175, the easy way is to write this as a product of two numbers such that one of them is a perfect square. Or do the factoring. So if I write it as 25 times 7 and separate it, 25 comes out as 5. Now, if you don't see that, you can do the factoring as follows by writing 175. Remember, it's not divisible by 2 because it ends with 5. It's not divisible by 3 because if you add them up, 1 plus 7, 8 plus 5 is not. You can divide it by 5 and you get 35. You divide by 5, you get 7. You divide by 7, you get 1. So what you're looking at is 5 squared times 7. 5 squared comes out. If it's easier, you do it this way. Now, for this one, again, I will do it in this fashion. So let me show you how it's done a long way, then I'll show you a faster and easier way. Because this is the index 3, we want to find 81 as a factor of two numbers. One of them is to the power of 3. So it's 27 times 3. This is x cubed times x squared. This is y to the power of 6 times y. This is z to the power of 6 itself. Now, this one comes out as 3. This one comes out as x. This one comes out as y squared. This one comes out as z squared. So we put them next to each other. The rest of them remain, and we are done. Now, instead of doing that, I would write this as follows. Let me show you the easier way. I would put this as 3 to the power of 4. Okay, so I'm gonna let me actually just do it this way. I'm gonna replace it right here, 3 to the power of. Now, you divide the exponent, in this case 4, by the index, and you get 1 with the remainder 1. So the answer would be 3 to the power of 1 out, 3 to the power of 1 inside the radical. X to the power of 5. Divide 5 by the index 3, you get 1 with the remainder 2. So you get x to the power of 1 out, x to the power of remainder in. This one, the exponent is 7, divided by the index gives you 2 or 1. So y to the power of 2, and the inside goes y to the power of the remainder. This one, 6 divided by 3 is 2 with the remainder 0. So there is nothing that goes underneath, but rather it's z squared. And then I put 3 to the power of 1, so it becomes clear it's 3xy squared. This is the better way and a faster way, I believe. Add or subtract as indicated. We are assuming variables are positive real numbers. So in this case, doesn't have a variable. So this is fine. 18, I hope you realize it's 2 times 9. So that means 9 comes out. So let me put the 9 first. So it's 9 times 2. And this one is 30. Well, let's just write it like this. So this comes out as 3. This comes out as 6. And this is minus 24. This is plus 24. Okay. And these two cancel each other. We have 7 squared of 2. By the way, it's important if you want to combine terms in this case, the radical part must be the same. So 7 minus 24 plus 24 is 7. All right, we want to look at part B. Again, you can write this the way, which is a long way. This is 49 times 2. This is x squared times x. This one is 16 times 2. This is x times y. You can write it this way. Or as I mentioned, just factor them out. Okay, this is 49 times 2. It's obvious. This one divided 3 by, remember, the index is 2. Okay, so this comes out as 7. So if this comes out as 7, 2 remains. X squared comes out as x. And we end up with 2xy inside. So this gives you 7. This gives you x. Over here, if you recall, I said 3 divided by 2, that gives you 1 with the remainder 1. That gives you the same. Over here, 16 comes out as 4. So this is 7x square root of 2xy. This is 12x square root of 2xy. And notice this part is identical to this part. So 7 and 12, 19 x squared of 2xy. They must be identical, otherwise we can't combine it. And that's the idea. We want to find the product, and all we have to do FOIL. So multiply these two, square root of 2 times square root of 8. multiply this 2 square root of 2 times -5, these two 3 times square root of 8, these two 3 times -5. As you know, this is 16 and this is -15. Now square root of 16 comes out as 4. This is square root of 16, okay? So this comes out as 4 and this is 6 square root of 2. And so we can combine these two into -11, these two into plus square root of 2. I hope you see -5 plus 6, they add up 1 times square root of 2. If I want to multiply this, I'm not going to FOIL. I'm going to remind you that A minus B, A times A plus B is A squared minus B squared. I hope you remember it and you know how to use that. So square the first one minus square the second one becomes 7 minus 10 or simply 3. -3, my apologies. Rationalizing denominators. How do we rationalize the denominators? If you recall, for a case like this, you just multiply by square root of 3 over square root of 3. These two, the product is 3, and the numerator is just 4 square root of 3, and you're done. The reason we multiplied it by square root of 3, that it could take it out. However, if you look at this one, and again, the denominator can't be 0. The exponent here was 2, so one of it would do the job, but here's the exponent is 3. So if I said cube root of x, I get cube root of, if I multiply by cube root of x over cube root of x, I get cube root of x squared. Doesn't do me any good. Because this is 3 and this has exponent 1, I need exponent 2 here. So I'm going to multiply by cube root of x squared divided by the same thing. Okay? You have to do this for it to work, everybody. Now, you can multiply and say it's cube root of x cubed, which is x, so just write it as x. The numerator doesn't change. Finally, on a case like this, when the denominator has two terms, two pieces, you multiply by its conjugate. Again, I remind you the concept of a conjugate. The concept of a conjugate, a plus b, the conjugate is a minus b, their product is a squared minus b squared. So we're going to multiply and divide by the conjugate of the denominator, namely 1 plus square root of 2. So what happens, the top is 1 times 1 plus square root of 2, which is itself. But now this 2, we use the product that was mentioned, 1 squared minus square root of 2 squared, which makes it 1 minus 2. And that makes this -1. So that changes the sign of the numerator, and the result will be -1 minus square root of 2 as the final answer.